Hello everyone, this is the Earth Archives. From centuries ago, whether light is a wave or a particle has been a focus of debate in the scientific community. However, after the double-slit experiment, it became even more confusing. Light actually has two properties. How on earth is this happening? Can consciousness actually change? Before the show starts, please help subscribe, like and turn on the little bell. This will help the Earth Archives grow. The show starts. The enigmatic nature of light. In the vast expanse of scientific inquiry, few phenomena have sparked as much debate, wonder, and intrigue as light. From the early musings of ancient philosophers to the groundbreaking experiments of modern physicists, the nature of light has captivated human imagination and intellect. This story embarks on a journey through the ages, exploring the pivotal moments and key figures who unraveled the mysteries of light, ultimately leading to the profound implications of the quantum realm. The birth of light theories. In the dimly lit study of a 17th-century Dutch home, Christiaan Huygens meticulously inscribed his thoughts on parchment. The flickering candlelight danced on the walls, casting shadows that seemed to come alive with his ideas. Huygens, a brilliant physicist and mathematician, was on the brink of proposing a revolutionary theory, light as a wave. Across the English Channel, in the grand halls of the Royal Society, another mind was at work. Isaac Newton, the revered natural philosopher, was formulating his own theory of light. Newton's experiments with prisms had revealed the spectrum of colors hidden within white light, leading him to a different conclusion. Light was composed of particles, or corpuscles. The stage was set for a monumental debate, with Huygens and Newton representing opposing views. Huygens' wave theory, detailed in his work Traité de la Lumière, described light as a series of waves propagating through a medium called the ether. Newton, on the other hand, leveraged his formidable reputation and empirical evidence to champion the particle theory of light. Despite Huygens' compelling arguments, Newton's status in the scientific community lent significant weight to the corpuscular theory. For a time, the idea of light as particles prevailed, overshadowing the wave hypothesis. Yet, the story of light was far from complete. The revolutionary experiment of Thomas Young. In the early 19th century, an English polymath named Thomas Young would reignite the wave-particle debate with a simple yet profound experiment. Young's double-slit experiment sought to shed light on the true nature of light. In a dimly lit room, Young set up a barrier with two narrow slits and allowed light to pass through them, casting shadows on a screen behind. To the astonishment of the scientific community, the light formed an interference pattern of alternating bright and dark fringes, a hallmark of wave behavior. Young's experiment provided compelling evidence that light behaved as a wave, capable of interference and diffraction. The double-slit experiment became a cornerstone of wave theory, challenging the long-held belief in the corpuscular nature of light. Young's work laid the foundation for future explorations into the dual nature of light and the mysteries of the quantum world. The dawn of quantum mechanics. As the 20th century dawned, the scientific community found itself at the threshold of a new era, the era of quantum mechanics. The discovery of the photoelectric effect by Albert Einstein, where light was shown to eject electrons from a material, provided evidence for the particle-like behavior of light, now termed photons. Yet, the wave theory was not discarded. Experiments such as Max Planck's work on blackbody radiation and the development of quantum theory revealed that light exhibited both wave-like and particle-like properties. This wave-particle duality became a central tenet of quantum mechanics, challenging classical notions of physics. The double-slit experiment, revisited in the quantum realm, revealed even more enigmatic behavior. When individual photons were fired at the double-slit apparatus, they still produced an interference pattern, indicating wave-like behavior. However, when observed, the photons behaved as particles, passing through one slit or the other, seemingly aware of the act of observation. This phenomenon, known as quantum superposition and collapse, suggested that the very act of measurement influenced the outcome. The implications were profound, hinting at a deep connection between consciousness and the material world. The quantum conundrum. In the heart of a modern quantum laboratory, Dr. Emily Carter stood before the double-slit apparatus, her mind racing with questions about the nature of reality. The lab, filled with cutting-edge equipment and the hum of high-tech machinery, was a far cry from the candlelit studies of Huygens and Newton. Yet, the mystery of light remained as tantalizing as ever. Dr. Carter and her team were conducting experiments to delve deeper into the wave-particle duality of light. They set up highly sensitive detectors to observe the photons as they passed through the slits, hoping to unlock the secrets of quantum behavior. To their amazement, the results continued to defy classical explanation. When unobserved, the photons formed an interference pattern, behaving as waves. When observed, they acted as particles, choosing one path over the other. It was as if the photons possessed an inherent knowledge of being watched, altering their behavior accordingly. Dr. Carter pondered the implications of their findings. Could it be that consciousness itself played a role in shaping the physical world? The idea was both exhilarating and unsettling, challenging the very foundations of scientific understanding. The conscious observer. As the implications of the modern double-slit experiment reverberated through the scientific community, a new wave of philosophical inquiry emerged. Scholars and physicists alike grappled with the notion that human consciousness could influence the behavior of light, blurring the lines between observer and observed. Dr. Carter found herself at the forefront of this discourse, engaging with thinkers from various disciplines. Together, they explored the philosophical underpinnings of quantum mechanics, revisiting age-old questions about the nature of reality, perception, and existence. One evening, as Dr. Carter gazed at the stars from her observatory, she contemplated the vastness of the universe and the intricate dance of particles and waves that governed its behavior. The quantum world, with all its paradoxes and mysteries, seemed to hint at a deeper, interconnected reality. Bridging science and philosophy. To further her understanding, Dr. Carter embarked on a journey through the annals of philosophical thought. She delved into the works of René Descartes, who famously posited the duality of mind and matter, and Immanuel Kant, who explored the limits of human perception. The writings of Eastern philosophers also offered intriguing insights. Concepts from Hinduism and Buddhism, such as the interconnectedness of all things and the illusion of separateness, resonated with the quantum view of reality. Dr. Carter found parallels between the ancient wisdom of these traditions and the cutting-edge discoveries of modern physics. Through her explorations, Dr. Carter began to see the double-slit experiment not merely as a scientific puzzle but as a profound statement about the nature of existence. The experiment's results suggested that reality was not fixed and objective but fluid and intertwined with the observer's consciousness. The quantum mind. As Dr. Carter's research progressed, she and her team began to explore the concept of the quantum mind, the idea that consciousness itself might operate on quantum principles. This theory posited that the mind could exist in a state of superposition, with thoughts and perceptions influencing the material world in ways yet to be understood. They conducted experiments to test the interactions between conscious thought and quantum particles. While the results were preliminary, they hinted at a profound connection between the mind and the quantum realm. The implications were staggering, suggesting that human consciousness might play an active role in shaping reality. Dr. Carter found herself both exhilarated and humbled by these discoveries. The boundaries between science and metaphysics were dissolving, revealing a deeper, more interconnected understanding of the universe. Chapter 8: A New Paradigm. The journey from Huygens and Newton to the modern double-slit experiment had transformed our understanding of light and reality. The wave-particle debate had evolved into a profound exploration of consciousness and existence. Dr. Carter's work, along with that of her colleagues, ushered in a new paradigm of scientific thought. This paradigm recognized the interplay between the observer and the observed, acknowledging the role of consciousness in the fabric of reality. As the scientific community embraced this new understanding, the implications rippled across various fields, from physics and philosophy to neuroscience and psychology. The quantum view of reality offered fresh perspectives on age-old questions about the nature of existence and the mysteries of the human mind. Chapter 9: The Legacy of Light. The story of light, from Huygens and Newton to the modern double-slit experiment, is a testament to the power of human curiosity and the relentless pursuit of knowledge. Each discovery built upon the foundations laid by those who came before, pushing the boundaries of understanding and revealing the intricate dance of particles and waves that underpin our reality. Dr. Carter's journey, like those of her predecessors, was a testament to the interconnectedness of all things. The exploration of light's nature had led to profound insights into the nature of reality, consciousness, and existence itself. As humanity continued to unravel the mysteries of the quantum world, the legacy of light remained a beacon of inspiration, guiding future generations in their quest for truth and understanding. Epilogue: The Eternal Quest. In the quiet solitude of her observatory, Dr. Carter reflected on the journey that had brought her to this moment. The dance of light, from its early debates to its modern quantum mysteries, had illuminated not only the physical world but also the depths of the human spirit. The quest to understand light had revealed a universe far more wondrous and complex than anyone could have imagined. It was a journey that transcended time and space, bridging the gap between science and philosophy, observer and observed. As she gazed into the night sky, Dr. Carter felt a profound connection to the cosmos. The story of light was not just a tale of scientific discovery. It was a testament to the enduring human spirit and the boundless possibilities of the mind. In the dance of particles and waves, in the interplay of light and shadow, the quest for knowledge continued, forever illuminating the path ahead.